Hi, my name's Dr. Pat Kiley and I'm CEO of Sentry. At Sentry, we're aware of the continuing pressures impacting operators of water and wastewater treatment systems. From a wastewater perspective, certainly conditions and wastewater conditions entering these wastewater treatment facilities are always changing. Also, the operators of these facilities have little to no real insight into how the biology driving these processes are actually performing. This lack of insight, this lack of real-time data requires these treatment facilities to be over-designed with added redundancy and certainly limits the ability of any process optimization to really focus on energy optimization. So, we always know the wastewater conditions are changing, whether it's diurnal trends in organic load, whether it's industrial clients discharging wastewater, whether it's inflow and infiltration from heavy rain events. And it's absolutely crazy to us to think that you have this massive piece of really complicated infrastructure being driven by biomass and microbial communities, but there are no tools to really tell the operators how this biomass and how these communities are actually performing in real time. So we developed Sentry. We started 7 years ago looking at how we can grow active biofilm on conductive surfaces. We've developed an end-to-end solution that has a sensor component where we grow naturally occurring bacteria from the wastewater streams in these wastewater treatment plants. These communities then respire to or breathe onto the sensor surface, and we simply take that signal in situ from the wastewater treatment process and display it on a dashboard. So in effect, we're taking the blindfold off the operators of these wastewater treatment systems and allowing them to see in real time exactly what's happening in their bioreactors. It's really simple. The clients receive the sensors, they install the sensors in the wastewater treatment process. We visualize the data on the dashboard. We set alarms around what is normal at the wastewater treatment facility, and then the dashboard is primed. When strange or unknown conditions in the wastewater are impacting the biology, the operator will receive a notification. These imbalance events are typically caused by industrial clients discharging big loads of organic carbon into the collection system. This is a spike in activity, or perhaps it's something acutely toxic to the biomass. And this would be seen as a big drop in activity on the dashboard. So we started installing commercial systems 3 years ago. What we didn't do at the time was tell our customers, look, this is the only way to install it. Install it here and just do this exactly. What we actually did is we asked our customers, this is our platform, this is our technology. How would you like to see this data? Where would you like to see the data? Where would the insight be most helpful to you? So over the last 3 years, we've developed 7 different problem statements, helping our wastewater treatment clients identify toxic discharge events in the collection system, profiling the wastewater coming into the wastewater treatment plant at the front end in these primary clarifiers, helping anaerobic digestion, co-digestion applications, and then going right through the removal process, whether it's aeration optimization, nutrient removal, or effluent monitoring of the wastewater leaving the treatment plant. For the Urban Water Challenge, we're really excited to work in partnership with a consultant for the World Bank, Daniel Alasco, and Sebespe in Brazil. Our proposed project is to install Sentry systems at 4 wastewater treatment plants. This is servicing up to 21 million people. The Sentry systems will be installed at the front end of each facility, profiling exactly the impact of key industrial dischargers, inflow and infiltration, diurnal trends of organic load, really giving a full profile of how all of these changes are impacting the biomass of the plant. And then after that, we're going to look at aeration optimization strategies. So providing a key insight to the aeration basins on the organic load and how it's impacting the biomass as a feed-forward signal, allowing operations to optimize aeration delivery before the wastewater even reaches the aeration basin. For the Urban Water Challenge, we're really focused on improving and targeting aspects related to SDG 6.3 and SDG 6.6. So looking to reduce toxic shock events and reduce plant effluent issues, and also demonstrating Sentry as a unique tool that allows for improved monitoring and optimization of the wastewater treatment process. or ask for support, what we'd like to get from our audience, introductions to new wastewater treatment clients, anyone who's having toxicity, wastewater change, wastewater imbalance issues. Also, any clients who are looking to aeration optimization, or anyone who's looking to save money or optimize their process at the wastewater treatment plant. Thank you very much.
Hi everyone, my name is Asim. I'm one of the founders of Fluid Robotics. At Fluid, we help keep water bodies pollution-free and cities safe. We're looking to address the problem of water pollution and the impact that it has not just on the environment, but also on public health. If we look at developing countries like India, about 80% of wastewater that's generated remains untreated and contaminates lakes, rivers, and coastlines. Even the United States has about 2.5 billion gallons of sanitary sewer overflows occurring daily. The solution that we've developed is our Fluid Health System that comprises of multi-sensor devices for data collection and an analytics framework for automating health assessment of wastewater infrastructure. In short, through our system, we map, inspect, and optimize wastewater systems across cities. Over the last few months, we've been deploying our solutions for COVID-19 detection in wastewater, developing models to help predict and prevent future outbreaks. We currently have deployments in a couple of cities in India. Our Fluid Health System has so far been deployed in 10 cities across India, and we've been able to monitor wastewater generated from about 7 million people. This has allowed these cities to intercept, divert, and treat more than 200 million gallons a day of raw sewage, which was previously contaminating urban lakes and rivers. This has had a huge impact on government savings because our solution utilizes and optimizes existing infrastructure. In a majority of cases, new treatment plants are not required. This has had a huge impact on lakes and rivers in these cities. We've also been able to generate pilot sales through our solution in these 10 cities. We're super excited to be part of the Imagine H2O program, and we really want to thank the team for selecting us as one of the Urban Water Challenge finalists. We plan to deploy a grant in Pune city for monitoring the wastewater entering Murha River. This is a 22-kilometer stretch of the river that passes through Pune and unfortunately gets contaminated along the way. This has an impact not just on Pune city, but also on the villages downstream that utilize this water for agriculture. Nidhi and I started Fluid Robotics about 4 years ago. I have experience building surgical robots before this for a company in Silicon Valley, and Nidhi has software product management experience with companies like Qualcomm and other fintech startups in Silicon Valley. We have a great team of advisors with experience in wastewater, enterprise software, and academia. And we have great partners that are helping us scale up our solutions in India and across the globe. We would like to thank you for this opportunity to share the work that we've done. Thank you.
Hi, I'm ROHINI. I'm Director of Insurance Products at Cloud2Street. We're a new kind of online flood monitoring and flood risk mapping platform that does not require infrastructure on the ground and instead leverages remote sensing, artificial intelligence, and crowdsourced community intelligence to build the best-in-class flood detection and flood risk management platform. Founded with seed funding from Google by 2 female scientists, our platform has been used by almost 20 countries and governments around the world. Now, we have partnerships with major insurance companies to take our proven technology and create the first scalable parametric flood insurance. Flooding is the costliest and deadliest natural disaster worldwide. Today, most communities around the world in both developing and developed countries do not have the information they need to respond to flooding, let alone flooding due to occur in the future because of climate change and increased rates of urbanization. Moreover, 70% of losses from flood-related disasters are uninsured. The status quo does not work for the scale of the problem because of manual and slow processes behind flood mapping, flood analytics, and flood insurance. Traditional flood mapping requires a lot of infrastructure and equipment on the ground that is expensive and hard to maintain. Traditional flood insurance requires that someone go out and assess your damages, meaning somebody has to go to your property and determine the impact and the extent of the damage you've sustained and the cause of that damage, which means that the payouts can take months to years to be paid fully. This means that the money is not reaching communities when they need it the most, hampering economic recovery. For example, the average claims processing time for Hurricane Harvey was around 64 days. Compare that to parametric insurance, where claims are paid out within 14 days of the event. Our technology enables insurers to do payouts and pricing differently. We're leveraging dozens of public and private satellites that are circling the Earth every day, and we have proprietary AI algorithms that then use this data to detect where floods are currently occurring and map where they may go in the future. By automating the process of flood detection and damage assessment, we allow the insurance process to be sped up with objective flood detection information. Using this information, we can make the insurance payouts, make sure that those payouts reach communities that need it the most when they need it. We're doing all this to make sure insurance is more transparent and flexible to the challenge of flooding, building economic resilience to this crucial water problem. With the Urban Water Challenge, we're going to create the first scalable community-based flood parametric insurance scheme that focuses on underinsured homes in the US. In the US, 9 out of 10 homes are not covered for floods, but 90% of natural disasters in the US involve flooding. Our deployment will be focused in coastal Louisiana, a place that is well familiar with the devastating toll of flooding. Using our technology, we will bundle homes that are underinsured and monitor those areas for floods with our proprietary flood detection platform daily. When the flooding is over a certain pre-agreed threshold, we will alert our insurance and community partners, causing the insurance to trigger and pay the community for the damage they sustained from the flooding, giving communities faster, more transparent, and more flexible flood insurance, and protecting the economic resiliency and livelihood of our coastal communities. Our technology allows for a new kind of financial safety net that responds to the growing flooding challenges the world faces. Our goal is to impact 10 million people with the new safety net in the next 10 years. We would love your support in hitting this goal. Thank you.
Hello, everyone. My name is Emily Morris, and I'm the founder and CEO of Emergy, based in Atlanta, Georgia. Our company has deployed the first distributed hydropower array in the United States and are now scaling our solution globally in partnership with GE Renewable Energy. My team and I are building Emergy to address the heart of the energy-water nexus in cities. With urbanization, the cost of pumping, treating, and moving water in cities continues to rise, in no small part due to increased electricity consumption. And this consumption is expected to more than double in the water sector by 2040. Compounding the issue are steadily declining water revenues in many areas, regulatory pressures for more water resources, and the choice of either unclean fossil fuel power or expensive intermittent renewable energy options for providing the needed electricity for water operations. As cities strive toward more sustainable development, they cannot be forced to choose between delivering clean water or using clean energy. Emergy's solution transforms urban water infrastructure into sources of clean, renewable energy using distributed hydropower turbines that harness and deliver power where and when it's needed most. Best of all, our equipment can be installed directly into water infrastructure without construction, making it an extremely cost-effective and rapidly deployable solution for cities of all sizes. Generating clean energy through water can be just as modular and scalable as generating energy from the sun or the wind, with the promise of greater reliability based on the continuity of water flow around the clock. The reliability contributes directly to the bottom line, representing a long-term energy asset that returns the investment often between 4 and 7 years, with a useful life of over 30. We partner with cities and empower them to utilize their water infrastructure, such as this wastewater treatment plant in Atlanta, Georgia, for clean power generation that can offset their energy consumption and their plant operating cost. While to date we worked with cities to invest into and acquire Emergy's power generation equipment as an on-site energy asset for the city, we will scale our solution through a market strategy that enables implementation of the equipment in municipal water infrastructure without a large capital outlay for equipment. With the award funding through Urban Water Challenge, our team will roll out a new deployment model that allows cities of all sizes to be able to utilize Emergy's solution, not just the ones that have the ability to make capital equipment purchases. We will partner with an urban water infrastructure owner to deploy an Emergy hydropower array and develop an energy as a service payment model that allows them to realize the benefits of the system without the upfront capital equipment investment. We believe capital requirements should not be a barrier to making the right decision for future water uses and energy sources of a city. An Urban Water Challenge provides the opportunity to prove that this model is not just the right thing to do, it's also something that can scale. This model is extraordinarily difficult to launch for a new company with limited resources, as it shifts the capital investment from the public sector to the private sector. Outside funding is critical to demonstrate the value of this model for cities, and we're grateful to work with Urban Water Challenge to deploy this exciting model. If we are successful, cities will be able to operate more cost-effectively by generating clean electricity using their existing water operations without an upfront investment into capital equipment. This enables more rapid, sustainable scalability and frees up capital to invest in other desperately needed public services. While Emergy directly pursues and tracks metrics related to SDG 7, increasing renewable energy, we recognize and take responsibility in our role as energy developers to the achievement of SDG 6, universal access to clean water and sanitation, as this cannot be achieved without reliable electricity. Our team combines decades in renewable tech development, hardware commercialization, and market growth. Our 12-person team has presence in all 4 corners of the US, with global partners in Australia and across the world with GE. I hope you'll follow along with our deployment with Urban Water Challenge, and I hope you'll consider partnering with us to turn urban water infrastructure into sources of clean electricity. If you work with cities who may benefit from lower electricity costs or more affordable water, please reach out to me. We'd love to talk with them. I appreciate your time today, and I'm excited to work with Imagine H2O to bring Emergy's solution to more cities globally. Thank you.
Hi. My name is KARINA PEÑA. I am the CEO of the Dutch startup Fuel Factors. If I tell you that we can use rainwater as a solution to tackle the impact of climate change, would you agree? Since our foundation in 2016, we have been helping the cities of Rotterdam, The Hague, and recently Madrid to become cooler, greener, and water resilient. Let me tell you how. By now, all of us have been confronted with the impacts of climate change. Too much water flooding our streets, or dried out parks due to the long periods of drought. It is clear that our cities were not built to deal with these extreme climate events. Municipalities and project developers are now being forced to implement rainwater management solutions on site in urban development and retrofitting projects. The current solutions are monofunctional, have a big footprint, or clog rapidly, and therefore result in high maintenance costs or a short lifespan. This shows the need for smart solutions for rainwater management that can be implemented in the limited urban space. And here is where we step in. We have developed Blue Blocks. Blue Blocks is a circular system for rainwater treatment, storage, and reuse in urban areas. We locally collect rainwater runoff from paved surfaces, such as streets or on roofs. We treat the water with a natural filter, a biofilter, to ensure that it achieves the high quality to be stored in the underground, in the natural aquifers, from where it can be recovered in the dry periods for later use. In this way, we create a local source for irrigation of sporting fields, or urban green, or for the children to play on the hot summer days, so saving the use of drinking water for non-potable uses. Blue Blocks is compact, reliable, and nature-based. It improves the spatial quality by adding green and enhancing biodiversity. And it fits beautifully wherever it is installed. And now you might be wondering how we do this. We target the urban water infrastructure market in Europe, with investments exceeding the 45 billion euros per year. Our customers are municipalities and big water users, such as football clubs. We work together with water utilities, water authorities, and end users to install our systems. We deliver our product through direct sales or via contractors in integrated design, build, and maintain contracts. In 2018, we installed our first pilot in the city of Rotterdam saving 15 million liters of drinking water per year. Currently, we are building our second pilot in the city of The Hague and launching other 4 pilots in other European cities. With the Urban Matter Challenge funding, we want to unlock deployment by helping our customers operate and monitor our systems. If we are successful, by 2025, we will have 20 circular water systems in operation, delivering 300 million liters of water per year. We will be your go-to partner to implement rainwater management solutions in cities. Field Factors is a young, ambitious, and multidisciplinary team. Really special about us is that we look at water not only as engineers, but as designers and storytellers. In 4 years, we have developed Blue Blocks from scratch, and with our hands-on approach, we are getting things done. And now is where you can step in. Do you know about the redevelopment project of an urban park, stadium, or new urban area that we can make sustainable by capturing and reusing rainwater? Please get in touch. Together, we can secure the freshwater availability for the future generations, one project at a time. Thank you.
Hi, I'm Kate, and I'm with Sanovation, a Kenyan-based social enterprise that's reimagining the way we think about sanitation. Sanovation goes beyond the toilet to ensure that waste is safely managed. As someone who spent 7 years in sanitation, I'm still impressed at just how few people actually know where their waste goes once they flush the toilet. Do you? In Kenya, 90% of waste just gets dumped into the environment without being treated. Local governments don't have the money nor the capacity to be able to fix this problem, let alone be able to scale to meet the rapid urbanization. As more people move to cities, waste continues to pile up, spilling into the environment and polluting the water. As a result, people get sick. In Kenya, diarrheal diseases is the second leading cause in death in children under the age of 5. But it doesn't have to be this way. Sanovation sees this as an opportunity to partner with local governments to solve the waste management crisis. We deploy a waste-to-energy model that not only cleans up cities, but creates jobs and saves money. Specifically, our treatment plant takes in fecal sludge from pit latrines and septic tanks. We then treat the waste, combine it with agricultural biomass like sawdust, and produce a firewood substitute that we then sell to industries. This revenue then covers our operational costs, allowing our plants to run in perpetuity. But before we invest millions in a citywide treatment plant, there's a lot of work that needs to be done to ensure that the plant meets the needs of the city. For the Urban Water Challenge, we will use these funds for feasibility study in Malindi, which is a coastal town of about 300,000 people, where there's only 1% of waste being currently managed. This feasibility work will then help us structure and secure project financing for building the actual citywide treatment plant. Our citywide treatment plants clean up cities, create jobs, and save governments money. In Malindi, the proposed plant would treat over 35,000 tons of waste per year, employ 35 people, and save up to 80% compared to traditional wastewater treatment solutions. We're confident that we can take our work to scale. Why? We've been doing this in Kenya for the last 7 years. Our team brings together international and national expertise to develop and operate long-lasting sanitation solutions. To date, we've deployed 3 other small treatment plants. And from this experience, we're confident that we have the knowledge and local connections to bring our work to scale. To take this feasibility project to reality, we're seeking an additional $4 million in capital. Beyond this investment, there needs to be a paradigm shift in the wash sector to think beyond the toilet. I want to challenge each of you to think about where your waste goes. Who's responsible for managing it, and who finances that? With more people thinking about where their waste goes, waste management can finally get the attention and resources it needs. Thank you for your time and allowing yourself to think beyond the toilet.
In 1908, US cities began to use chlorine to disinfect its drinking water. And to ensure chlorine levels were safe, the utility would take grab samples from the distribution system. Fast forward today, around 98% of water systems in America use chlorine in their disinfection process. And guess what? They still sample residuals the same way they did over 100 years ago. It's no wonder that recently over 63 million Americans were exposed to unsafe drinking water. And for over a century, water utilities have performed routine sampling to answer a timeless question: what's going on? And specifically, what's going on in my distribution system right now? I want you to meet Darren. He's one of our clients. Darren's seen here flushing the system to increase chlorine residual levels in the northeast part of the city, where the demand for water is lower than expected. But prior to actually taking this action, Darren had to drive 13.2 miles to this location, turn on a spigot, take a grab sample using a kit, record it on a piece of scratch paper, determine the corrective action to take, drive back to the treatment plant, log it onto a notepad, and maybe it made it to Excel. Listen, you get the idea. It's a really, really cumbersome process. And Darren, along with countless of other techs across the nation, do this every single day. Something has to change. We've arrived at a point in time where utility managers can either let these macro trends continue to create unbearable pressures on their operations, or they can change the way they do things. And Varuna knows that water system managers will opt for the latter. And that means using data. Varuna is reimagining how to use data to run a sustainable and resilient water utility. And we enable water operators to see beyond the fence of the water treatment plant into their distribution system. We do this by deploying nodes that are outfitted with water quality sensors, and the data is then transmitted to the cloud, where we run analysis and provide situational awareness to the operator so they can make the best decision about where to spend their time and money. So now the operator has visibility across the distribution system to understand what's happening in real time with things like chlorine residuals, pressure, and turbidity. And in Darren's case, with enough data, we can begin to predict contaminant shocks and recommend optimal remediation workflows. Varuna is focusing on small to medium-sized utilities in the 2 states you see in front of you, as they represent our beachhead market. And it's paying off. Since the pandemic brought the US economy to a screeching halt in March of 2020, we've gained 5 new customers. We've been selected to the Urban Water Challenge. We were awarded a grant from Google, and we've signed an MOU with the largest water company in Mexico, as well as a global engineering firm. And to top it off, we've secured a term sheet from Corazon Capital as we move to raise a seed round. We're repeat founders, having sold our first startup, Power to Switch, about 5 years after it was founded. And we're supported by an amazing group of advisors like Johan Schwinn, who's a savant when it comes to practical IoT design, especially in the water space. Aside from our team, Varuna's unfair advantage is in our systems thinking approach to building software in our price segment match that allows us to provide more value than our competitors and do so at a reasonable price. We're excited about receiving the Urban Water Challenge Award because it helps unlock the vision we have for Varuna and for the water industry. And part of that vision includes enabling cities to deploy advanced technology that helps underserved and underrepresented populations. And 2, also just eliminating the inequities associated with access to clean water. And with that in mind, we'll deploy a full Varuna system in these 2 cities to achieve that vision. Now, if we're successful, we can change the way utilities operate, ultimately enabling them to consistently deliver clean drinking water to all citizens. We're raising a $1 million seed round led by Corazon Capital, and we'll use these funds to get us to our next milestone of working with 20 water utilities to give them visibility, awareness, and insight of what's happening throughout their distribution system. Water utilities understand there's too much at stake for them not to know what's going on in real time. And Varuna is helping get them to that future state. If you're interested in joining us on this journey, we'd love to chat with you. Thank you.
My name is Aaron Tartakovsky. I'm the co-founder and CEO of Epic Cleantech based here in San Francisco. So we are decentralizing wastewater treatment and reuse into individual buildings or groups of buildings starting in cities. So what are the big problems that we're dealing with? Well, right now we continue to be reliant on centralized infrastructure. We're dealing with water and sewer rates that are rising on top of continuously unpredictable climate, and the fact that we know that 70% of the world's population will be living in cities by 2050. So we see an opportunity not just to continue rebuilding the same way we've been doing things, but to fundamentally shift the model towards a more distributed approach. So why cities? Because of this statistic. We know that more and more people are going to be moving into cities, and we have an opportunity to redesign how our cities handle both water and wastewater infrastructure. So at Epic, we've developed an approach. We actually convert a building's wastewater both into treated water, which we can then reuse on site, helping to reduce a building's water demands by up to 95%, as well as a high quality carbon-rich soil product, which we can then use in and around cities. And very importantly, we handle everything for these projects, meaning we handle everything from the initial permitting and design all the way through the ongoing operations and maintenance contracts of these systems, essentially hand-holding our customers, which are building owners and developers, to make sure that this entire process is as seamless as possible. So what does it actually look like? We are going into the basements of these large buildings or these campuses. We're first pulling out the solids. So these solids we strip out of the water, we compress, we take offsite and turn into high quality soil products, which we can then partner with cities or with parks or with nurseries to turn it into a high quality carbon rich product and actually not have to use fossil fuel based fertilizers. With the solids now removed, the water, which is more akin to a dark gray water, can then be treated and recycled on site. And in terms of the technology that we're actually using, here on the left, you can see our solids recovery technology. This is a rotating belt filter, which has been sized specifically for a building, which is to say it's not large flows like you would see at a wastewater treatment plant where you're talking hundreds of thousands or millions of gallons a day. We're talking anywhere from 500 gallons to maybe 100,000 gallons per day, which means we can design the technology differently for those applications. On the right, you're seeing the membrane bioreactor that we are working with. So we've actually partnered in an OEM relationship with an existing player to design a system that's designed to be able to integrate into a building for those lower flows and to be able to fit into, for example, a 9-foot basement. This is actually the design of the system that we'll be putting into one of our installs in the coming month. This is what we do with our solids. So on the left is the raw solids. These are from Stanford where we did our initial testing. We convert it into a high quality soil product. So what you're seeing is not a stock image. That's actually our scientist Elon's hands holding our finished product. And this is actually our first hub. We call these Epic hubs. Each hub can service multiple buildings or spokes. Here is our first facility where we are creating this product and able to use it locally. So the business model is quite straightforward. We're selling these systems for about a 45% margin. We then have an ongoing O&M contract for 10 to 20 years. Again, about 45 to 50% margins there. And then we're finally selling the soil product, which is sort of a tertiary source of revenue for us. As time develops and the market matures, we plan on doing more of a leasing style model similar to the solar industry, using either third-party financiers or dedicated project development funds. San Francisco is our beachhead market. We actually worked on the regulatory side to help pass a law that requires that all large buildings in San Francisco have to have on-site water recycling programs. We also spent about 2 years on the state level on something called Senate Bill 966, which says that any city in California that wants to have a water recycling program like San Francisco's can do so, and the state regulatory authorities will help. And we envision other cities will be following suit in the coming years. This is actually an example of a project that we would be working on. And you'll see that by installing our system and reusing water on site, this building will save almost 40% annually, which translates to close to $700,000 or compounded over 10 years, $6.7 million. Our team is interesting. We are multifaceted. We cover politics, we cover engineering, we cover science. And we think that those three things are key ingredients to being able to navigate not only a new technology, but being able to work within a very regulatory heavy industry like water and wastewater and in the real estate sector. And we also have investors and advisors who span everything from real estate to water, to energy, because we want to be able to think differently and work with our regulators versus against them. We've had a very busy year. We completed 18 months of testing at Stanford. We deployed into our first building in downtown San Francisco. We actually recently closed a $2.6 million seed round, and we have a lot of projects in the works now. But one thing I'm most excited about to actually announce on this call is on the left here. It will be our first commercial install, which we are commissioning in the next month. So I invite you all to come see it, should you be in San Francisco. Finally, I'll say that Epic Cleantech is very excited to be part of the Urban Water Challenge for 2020. We're excited to use this funding to be able to accelerate our developments and to make on-site reuse not just a one-off thing in a city like San Francisco, but to actually help to streamline regulation and streamline the education with our key stakeholders like building owners, like developers, like architects, who frankly are not familiar with on-site reuse. And so we as Epic Cleantech aim to be the leaders in the field to make this not only a one-off thing that certain projects will do, but to make it a mainstream approach that all new developments will want to be reusing their water on site and will understand the regulations and the technologies that enable them to do so. So what are we looking for now as a company? Well, we're looking for customers. We want to partner with more folks in the real estate industry, and we want to bring this solution to more cities. We want to work with other utilities. We want to work with other technology partners to make this not only something that we can do in San Francisco, but in other cities across the country and eventually around the world. So thank you very much. Appreciate your time. Anyone can feel free to reach me by my email. I look forward to continuing the conversation and working with you all. Thank you very much.